The Collatz conjecture, also known as the 3n+1 problem. It is a simple rule, yet an unsolved mystery that has puzzled mathematicians for decades. What exactly is the Collatz conjecture? Start with any positive integer. If n is even, divide n by 2. If n is odd, multiply n by 3 and add 1. Repeat this process until you reach 1. Let's take an example, starting with the number 7. Since 7 is odd, we multiply it by 3 and add 1, which gives us 22. 22 is even, so we divide it by 2 to get 11. 11 is odd, so we multiply by 3 and add 1, resulting in 34. 34 is even, so we divide by 2 to get 17. 17 is odd, so we multiply by 3 and add 1, giving us 52. 52 is even, so we divide by 2 to get 26. 26 is even, so we divide by 2 to get 13. 13 is odd, so we multiply by 3 and add 1, resulting in 40. 40 is even, so we divide by 2 to get 20. 20 is even, so we divide by 2 to get 10. 10 is even, so we divide by 2 to get 5. 5 is odd, so we multiply by 3 and add 1, giving us 16. 16 is even, so we divide by 2 to get 8. 8 is even, so we divide by 2 to get 4. 4 is even, so we divide by 2 to get 2. 2 is even, so we divide by 2 to get 1. Here is a simple implementation of the Collatz conjecture in Python. We define a function called Collatz that takes an integer n as input. We initialize a list called sequence with n as its first element. While n is not equal to 1, we check if n is even. If it is, we divide n by 2 using the floor division operator. Otherwise, if n is odd, we multiply n by 3 and add 1. We append the new value of n to the sequence list. Finally, we return the sequence. The Collatz conjecture states that no matter what positive integer you start with, you will always eventually reach 1. In mathematical terms, for all n belonging to the set of positive natural numbers, the sequence ends at 1. The Collatz conjecture works for all tested numbers up to 2 to the power of 68, but no mathematical proof exists to show that it works for all numbers. Therefore, the challenge lies in proving that it works for all positive integers. The Collatz conjecture has some fascinating properties. Numbers can reach astronomical heights before dropping to 1, exhibiting unpredictable growth. Additionally, the sequence lengths and maximum values appear to be chaotic, with no discernible pattern. In conclusion, the Collatz conjecture is simple to understand, yet impossible to prove. It remains a perfect example of mathematical elegance and mystery. As William Paul Thurston said, mathematics is not about numbers, equations, computations, or algorithms. It is about understanding. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.